Hello, everyone.
So Stella is here to talk to us about the analysis of burnt scar using optical and radar satellite data and its time. And take it away, please. And also, could you maybe make it full screen if possible? Uh, that would be easier for us to understand and read.
Just that way.
Oh, okay, cool, got it, awesome.
Okay. So, hi, my name is Stella Chelangat from Kenya. I am a geospatial analyst. I work with IFA, that's International Fund for Agriculture Development. I am a recent MSc graduate of University of Twente. That's why I did my analysis of Banska in my thesis. And I also have a background in my Bachelor's of Geospatial. I did it in Kenya. So glad please have a small presentation. I didn't put all the images, but I believe it will work well. So I'll start with background for analysis of Banska. So most of the time we've realized that effect of wildfires in forest has attracted both recognition both locally and globally, with recent fires being even in California. And so in my analysis, I tend to understand the gap or variation of using optical and radar, especially in terms of geographical aspect. Past studies have been done on comparison between optical and radar, but very few or almost none has done a comparison of effect of optical and radar based on variation of geographical aspect between two different areas. So for mine, I selected Australia, Victoria, Australia, and Spain. My main objective for my undertaking study was mainly to analyze the use of SAR and also its comparison to optical images. And for my understanding, it was to identify classification of both burnt and unburnt patches. I was dealing with post-fire hazard assessment. So that's fire, like I was analyzing images after the fire. So my specific objectives were only for one was to develop a burnt severity map. This was to enable me understand the size and the extent of the fire. Number two was to explore the sensitivity of both polarimetric sensitivity or decomposition and backscatter intensity. This is using SAR to be able to identify both burnt and unburnt. Number three, I was able to also determine the degree of spectral contrast. So this is basically using of optical in determining of burnt and unburnt. And lastly, I was able to do textural analysis. This is to understand also the behavior of texture in terms of identifying burnt and unburnt. And specifically, I use backscatter intensity. Yeah. My methodology or my observation basically was I used contextual classification, that's support vector machine, and then afterwards I used Mark random field, that's MRF. This is because of smoothing around the edges or mainly around the boundaries, and also to remove pixel mix classification around the edges. I was also, in terms of SVM of Sentinel-1, I was able to classify both backscatter and H-alpha decomposition. And then I was also, with the same results, I also did, in terms of SVM MRF classification, I did it also for optical. In terms of my training sets and my training and test sets, I used the burnt ratio index as the vegetation index for me to be able to identify. So I'll go straight to my discussion. So initially, before I began my analysis for Sentinel-1 and Sentinel-2, I selected 3 fire zones, mainly in Australia. And there were 3 fire zones because one was a hilly area. You can see fire 1 around this place. And then also fire 2. Fire 2 zone was a steep slope. So fire 1 was just a flat area. Fire 2 was a steep slope. There was a reason why I selected those 2. I wanted to understand the impact of using SAR in both a flat area and a hilly slope, and if they can be able to show any difference. First, I was able to perform backscatter analysis. I was able to do a graph analysis mainly of backscatter against local incidence angle. And there are some few particular characters that I realized as I was doing my study. One is that whenever I did backscatter on a flat area, the areas that had small incidence angle showed the high difference between burnt and unburnt vegetation compared to areas that had steep slopes. Now, also, if we look at the length based on my analysis here, okay, sorry. Okay. Okay. Sorry. So based on my analysis, initially when I do the backscatter mapping against local incidence angle, I could look for fire zone one, which the area was a little bit flat. The incidence angle, the range of incidence angle was between 0 to 30. So it showed a lot of, how do I say, how a lot of difference between burnt and unburnt areas. But when you look at a flat area like fire zone 2, if you look at this graph here, you'll realize there's no much difference, and the rate of, of incidence angle was very small, 0 to 18. So this could show you that steep slopes, most of the time steep slopes experience are a big factor in Sentinel-1. And so sometimes due to topography nature, the radius, or rather the backscatter intensity, does not reflect well, so it appears to have shadows. So the ability to detect burnt or unburnt areas was very difficult in this particular area. Also, when I did my SVM MRF classification, I only picked one area because I didn't want to explain much. This is for fire zone 1 and 2. You'll realize for optical, which is Sentinel-2, it tends to depict the picture a lot. You'll realize most of the burnt areas, which is red, and unburnt, which is green. But if you look, you can't see much difference with Sentinel-1. So one of the things I realized, areas that were unburnt in optical were burnt in Sentinel-1. So this could show you that optical mainly selects only, because it's based on spectral capabilities, it only selects vegetation, crown, or crown field. But however, when you look at Sentinel, it normally selects branches and crown leaves. So it was highly removed. So that's why mostly in Sentinel-1, or rather in radar, it tends to classify the unburnt, the it tends to classify those areas that are some parts that are burnt in optical, unburnt in optical, as burnt here. And most of the time when I did a vegetation index, the areas, because it came out into 4: burnt, highly burnt, medium burnt, and lowly burnt. So the low burnt areas were highly burnt, or were considered as burnt in the Sentinel-1. Also, another thing when I was comparing the vegetation index is that I noticed, um, when you compare between classified and the vegetation DNBR, you'll notice that when I did my classification analysis, areas that were areas that had houses and buildings appeared as burnt, because they were carrying the same, how do I say, spectral color or spectral index with areas that were burnt in my vegetation index. So that can cause a lot of misclassification errors. And actually, one really needs to pay attention when they're looking at classification accuracy. The accuracy might be high, but it does not mean that your results are very clear. Last in my analysis is that I did a boundary classification. I obtained boundaries from what is it called, from Australian bushfire, Victoria Australian database. And so the reason I obtained was for it to show me the areas that were highly burned. And for that factor, I selected areas that had a high index of burning and recently occurred in between 2018 and 2019. So I realized after my classification is that the boundaries were not exactly fitting my classification results. So one can worry, why is that? But I closely looked and realized when they were taking the digitization vector of the areas that were burned, they must have done it at the initial particular points of the fire, like at the initial stages of the fire. But my analysis is highly based after the fire. So when you look at these particular two comparisons, you'll realize that my analysis was done a month after the fire. So they might have continued burning even though they took some polygons, but does not mean they took all of it. So this is a key factor that one would emphasize, that anytime they're taking polygons for fire, next time is to take them even a month after the fire. So this can be able to act as very good training sets in terms of validating one's particular test. Lastly, when I was doing my textural analysis, I could not be able to show it here because it was just on a statistical basis. I realized that when it comes to texture, when I used backscatter intensity, it could be able to show me, but it was very difficult because the intensity of the fire was not that much for it to distinguish. And so most of the time, maybe if I use maybe ALOS2 one that has more bands, it could help me understand it. Last but not least, as I'm about to finish, my conclusion of the results was that it was still successful to both use optical and radar satellite data. Now, the difference that I want to note out is that when I used Sentinel-1, that is SAR, in Australia, it was able to map out for me a fire, a burnt and unburnt, in all the three fire zones. However, when I used Spain, it could not be able to show me anything. And that could be as a result of the intensity of the fire. In Spain, it was not that much as compared to Australia. And so that's also a factor that needs to be considered when you're doing forest fire analysis, how much the intensity of the fire is. Because if it does not remove vegetation, crown of vegetation, leaves and branches, then say SAR cannot be able to really map it out contextually well as it did in Australia. Also, another thing I'd like to emphasize is that the sensitivity of SAR for me had a lot of hampers because one, the vegetation structure in both areas were different. Number two, the geographical aspect of both areas. As I told you, in Spain, it was not able to map any part of it, but in Australia, it was. And even if in Australia, it was, I selected three bushfire zones. Fire one, which is the only one I've highlighted here. So, but fire two and fire three were steep slopes. And so they had less, how do I say, it was difficult to identify burnt and unburnt in those particular areas, especially steep slopes, because some appear as shadowed areas, so I couldn't be able to see the difference as compared to a flat area, which was fire one. Also, another factor that one needs to consider when using SAR is the correction of the local incidence angle effect, the acquisition geometry, and even the environmental aspect. For me, I was lucky to have collected my images or selected my study area during dry seasons, because if you collect it during wet seasons, then it might affect your study. And then last but not least, one needs to consider the timing of the data sets, especially with post-fire. One of the things that I did when I was selecting my images, I selected images before and after the fire. However, just a month before and after the fire, so that if I did it like 3 months after the fire, so there would be this post-regeneration of vegetation. So I would not be able to get a clear aspect about how much has changed. Considering the fire has occurred, some areas grow very fast after the fire, and so it will not be able to be a good analysis for me. Last but not least, I realized sometimes if in consideration of Spain, where SAR does not work out well, one can be able to combine both optical and SAR in the analysis. However, I was not able, due to the timeliness of the time of the project, I could not be able to do much into combining both optical and SAR into one so that I can do the analysis on Spain. But in case you cannot be able to do it, you can use optical in terms of a reference. And last but not least, my next immediate steps was had applied for SAR such as ALOS2, ones that have more longer wavelength and more polarimetric bands, so that I can understand will it have the same effect as a single band like Sentinel-1. Also, the last is using L or P band, which are longer wavelength bands than C band. So with that, I can be able to, because we're using C band, I was not able to perform band severity levels. So I was hoping if I use L and P band that have more bands, I will be able to perform band severity levels. What I'm looking forward is to also perform. I only used H alpha decomposition. I'm looking into doing more target decomposition like cloud and Poitier decomposition, and compare different decomposition method using ALOS or SAR data. Lastly, my challenges were, one was that visual interpretation of radar images were very difficult. Sometimes I had to use RGB component, that's the entropy and the alpha decomposition. Co-registering of the optical data sets were also quite difficult, especially because they were obtained in different seasons and dates. And last but not least, SAR needs a lot of time processing, and also the memory of the computer has to be large. So it was quite a hamper for me. So I couldn't do much at that particular time. And even if I did, I used to delete immediately after my analysis so that I can create more space. So probably someone who's looking forward to do the similar results or similar challenges or similar using SAR needs to consider space as a critical aspect. Yeah, so I'm done. Thank you very much.
Hey, thank you so much for the talk. You're actually done quite early. You still have, I think, 15 minutes left to go
Okay.
over. You're done quite early. And also another thing which I would first of all, thank you for the talk. But I think you're able to see a lot of the stuff because you are sharing your whole representation on a single screen. So, for example, you have
Yeah.
those the flow charts of analysis and also the next steps, right? So those stuff are not
Okay.
really visible. So it will really help if you could share your slides with the people so that they can connect like what you said to what is here. And also, let me look at if we have any questions. Oh, and also a quick reminder, we have a Q&A section on Zoom where you can submit your questions to the speaker. Uh, I don't feel like people are using this. And also, you can also ping on Discord now or later, anytime. You can just add the speaker and ask your question. I think the speaker would be available on Discord even later. Uh, we still have
Yeah.
we still have time to kill. So, do you want to say some closing remarks or anything, or should we just close out and wait for some time? It's your call.
Oh, thank you. I welcome. I'll share the slides. Definitely. I try to compress them into one because of time. I didn't want to. I felt like the time limit was keeping for me, so I didn't put much of the images. But I'll share them so that people can zoom in and ask any question that they have. I'll share them with you. Then you can help them upload it. Okay.
Awesome, that's amazing. Thank you very much.